Okay, 3, 2, 1, it's jam.
What's up, science fam? So in this picture, we can see that there's something like sticky, gooey looking, but when you touch it, it seems like it's glowing red hot. What is this stuff and where exactly does it come from? We're going to talk about that in this session. My name is Sir Ramon and this is Science with Sir Ramon. So our topic for this session are volcanoes. So these are things that go boom, eruptions and stuff like that. We're going to talk about the types of volcanoes, their hazards, and other concepts regarding volcanoes. So what are we up to? Again, we're describing different types of volcanoes, differentiating between active and inactive volcanoes, explaining what happens when volcanoes erupt, and illustrating how energy from volcanoes may be tapped for human use. This is a two-part session. This is going to be the first part where we focus on volcanoes, the types, their anatomy, and so on. So volcanoes, what are they exactly? We have this general idea in our heads of like triangle-looking things that spew out lava, but their definition is basically any place where volcanic gases and magma come out of the ground. So again, as long as there's a rupture in the crust of a planet and the inner magma starts spewing out, that is considered a volcano. Even a crack in the crust in the ground that doesn't form a mountain is considered a volcano. Now, when we say magma, that's different from lava. These are two different terms. You can't interchange them. They're referring to something with the same composition, but their difference is where they are. Lava is molten rock that has reached the Earth's surface. So anything that's on the surface of a planet that is a molten rock is called lava. On the other hand, if it's underneath the ground, if it hasn't reached the surface yet, that's when we call it magma. So again, there is a distinction: magma underground and lava above ground. All right? Next. Most of the volcanoes in the world are found on what we call the Pacific Ring of Fire. So this is actually forming the boundary of what we call tectonic plates, which we will discuss in a later session. But all you need to remember is that more than 3/4 of Earth's volcanoes are found on this ring of fire that is bordering several continents. And looky here on the west side, there's the Philippines, right on the very rim of the Pacific Ring of Fire. And that's why we are discussing this topic in this session, because we have a lot of volcanoes in our country. Now, what happens when the stuff comes out? When stuff comes out of that volcano, not all eruptions are the same. Some are worse, some are more gentle, and these are the factors that determine an eruption. So there are two main types. There's the explosive on the left side and the quiescent on the right side. Explosive is self-explanatory. Quiescent means it's more quiet, it's more chill. Although it's still hot, so it's not exactly chill. So they're mostly determined by the viscosity of the magma, how thick that magma is. The more viscous it is, the more thick the magma, the more explosive the eruption. So again, the thickness, the viscosity of the magma determines the explosivity of the eruption. So what does make it thick? What gives us thick magma? So these factors affect it. Factor number one is temperature. Hotter magma means it's less viscous. It becomes less thick because it's being it's closer to a liquid state when it is hotter. So you can see here in the GIF the cheese, which is a solid block of cheese, when it gets hot, it becomes less viscous, meaning it flows more. Again, viscous means thick and less flowing. Less viscous means that it flows easier. Now, factor number two is the composition of the magma. When there's more silica in the magma, it becomes more viscous. Silica is something that is a primary component in glass. So you can see in this GIF that glass can be shaped because it's high in silica. It's very viscous. It's very thick. So your magma, if it has a lot of silicates inside it, it becomes more thick, more viscous, and can cause more explosive eruptions. Factor number three, dissolved gases. When there's more gases like water vapor and carbon dioxide, your magma becomes less viscous. But at the same time, even though it's less viscous, it's also more explosive. So it's less viscous because the gases make it easier for it to flow, but it's more explosive because those gases push on the molten rock when they get very, very hot. So in an eruption, because of the gases, it can become more explosive, just like this poor person in this GIF here. So what comes out during an eruption? What materials do volcanoes eject? So when a volcano erupts, these are some of the things that come out. First, of course, your lava flow. So there are three main types of lava flow. There's the lava flow, which is more viscous. So when your magma is very viscous, it creates a very rough, slow-flowing lava. So the reason why it's rough looking is because it's starting to um, solidify or crystallize as it moves, creating jagged edges. On the other hand, this other type of lava flow, pronounced pahoehoe, is less viscous and looks ropey because even though it's kind of viscous because it's molten rock, it's less viscous than in a lava flow. So it flows very fast and tends to harden in a slower manner as it flows, creating a smooth surface. Pahoehoe literally means that which you can tread on or walk on, because when it solidifies, it's relatively easy to walk on this type of lava flow. The third type of lava flow is pillow lava flow. It literally looks like crap, just long tubes of crap, and it only happens in underwater volcanoes because the water immediately cools down the lava and turns it into, these gigantic lava turds. Now, material number two are volcanic gases. It's mostly water vapor, but it also contains some sulfur and carbon-based compounds like sulfur dioxide and carbon dioxide. And take note that these volcanic gases are both A, acidic, which is responsible for acid rain, and B, greenhouse gases. So actually, these volcanic gases have a pronounced effect on the climate of an area. So an eruption isn't just, lava and hellfire and brimstone, it's also climate change. Material number three is tephra, otherwise known as pyroclastic materials. This is basically solid stuff that comes out of the volcano. It could be as small as dust. When it's as small as dust, it's called volcanic ash. A bit bigger than dust, small little tiny pebbles are called lapilli or cinders. Cinder is an important term which will identify one of the types of volcanoes later on. And we have the bigger ones, volcanic bombs. These are big enough that they're like small, rather large rocks actually, that they look like rocks when they're going through the air, but when they finally land, they're like bombs because inside is molten rock. It's still lava inside. So it's like a bomb because it just shatters and, sends lava uh, splittering around. Volcanic blocks, on the other hand, are very, very large boulders that become ejected in a violent and explosive eruption. Now, we talked about the stuff that's being ejected outside, but what's on the inside of the volcano? Our mamas always say it's what's on the inside that counts. So let's talk about the anatomy of a classic volcano. So these are the basic parts of it so that we are clear on the terminologies. When we say vents, these are openings on the surface. So again, they can be at the very tippy top of a volcano, hill, or mountain, but there can also be side vents on the sides of the volcano. So these vents can also secrete lava from them. So again, any opening at the surface is a vent. A crater is a funnel-shaped depression. This is usually at the very top, tippy top of a standard volcano mountain. So that's what we see. So again, craters and vents are different things. The vents are any openings, while craters are funnel-shaped depressions. They're not necessarily openings where lava comes out. Conduits are the main paths of magma out of the magma chamber. So it's like the main tube of the magma to exit out of the Earth's crust. And finally, there's also the term caldera, which we separate from craters because these are craters formed by collapsed magma chambers. When their entire mountain collapses into its magma chamber, that is a caldera, right? Now, are all volcanoes the same? The answer is, of course, no. There's lots of many types of volcanoes, and how do we classify these types? So we classify them mostly on their shape and their properties. Type number one is a shield volcano because it looks like you take the Captain America shield, you lay it down flat on the ground. That's what a shield volcano looks like, except massive. They're huge. Most of the largest volcanoes in the world are shield volcanoes. In fact, the largest shield volcano and also largest volcano in general in the world is Mauna Loa in Hawaii. So these shield volcanoes have very gentle slopes because their lava flows tend to be very gentle as well. So the lava just dribbles out of the hole and goes to the sides and then forms layers upon layers of solidified rock. So that gives it a very wide base, very gentle slopes. That is a shield volcano. Type number 2 is a cinder cone volcano. Now, remember Tephra, the solid fragments that are ejected from a volcano. One of the types is the cinder. So lapilli or cinder are what make up a cinder cone volcano. So they're made of cinder fragments, very tiny pebble-like fragments, as well as solidified lava. So because they're made up of tiny fragments with lava as a cement between them, that kind of develops very steep slopes, and it doesn't develop into very large mountains. They're kind of short and stout. So they're pretty much just mounds of volcanic material, and they're usually made from a single eruption event that created the cinder cone volcano, and then usually they don't erupt anymore. They just erupt that one time. Now, type number 3 is a stratovolcano, also known as a composite volcano, because it's made of both solidified rock, like in shield volcanoes, as well as cinder fragments, like in cinder cone volcanoes. So both of them in equal amounts. So in composite volcanoes or stratovolcanoes, because of the composition, they are not too steep and not too gentle in slope, and they tend to be very symmetrical, like Mount Apple, because of how they form. Now, they're formed from very viscous lava, and that usually means that their eruptions are very explosive and dangerous. So, volcanoes like Mount Apo, stratovolcanoes like that, they tend to be some of the most dangerous types and some of the most active types of volcanoes. Now, what makes volcanoes dangerous exactly? What are the hazards of volcanoes? Of course, the first is obviously lava flow. It's the one of the types of materials that volcanoes are known for, and I mean it's molten rock. You expect things to burn up when it touches something really, really hot. But just to emphasize how hot lava is, some things can burn even without direct contact with lava because it's just that hot. If you take very flammable material and put it near lava, not even touching it yet, it can ignite already and start burning, like Anakin over here. Hazard number 2 is pyroclastic flow. A bit lesser known, but uh, just as, if not more dangerous than lava flow. See, lava flows very, very slowly. You can kind of briskly walk away from it unless it's pahoe-hoe lava flow. But pyroclastic flow is very, very fast. It's like a very hot avalanche. It's made up of gases, ash, lava, and rock. And it goes so fast it can outrun cars and jeeps. And it can bury and burn entire towns. So the gases lower the friction of the entire plume of cloud, making it travel very, very fast, faster than most other things. So it's faster than a snow avalanche. Hazard number 3 is a Lahar flow. If the pyroclastic flow is made up of fragments and dust and rocks and stuff, very loose material, the Lahar flow is very thick and very heavy because it's basically a volcanic mudslide. The volcanic ash mixes with water and creates this sludge that flows down the mountainside of a volcano. So since it's water and volcanic debris, it's hot, it flows very fast, it follows the path of streams and valleys, which are normally where your civilization starts. It's normally where you put your towns because you need a water source. So this is a very, very pronounced danger or hazard in volcanoes. Now, there are also secondary hazards. These are not always seen with volcanoes, and they're considered secondary because their effects are more long-lasting rather than immediate and severe. So one is the tsunami, volcanic tsunami, which only happens with violent coastal eruptions. So eruptions in the middle of in midland will not cause a volcanic tsunami. On the other hand, ashfall, and volcanic gas can spread over a very wide area. Our recent Taal eruption is an example of that. Even places far from Taal volcano received a liberal sprinkling of volcanic ash. Now, this ash and volcanic gas can have very lasting effects on the air quality, so the respiratory systems of people can be affected, on soil quality, so agriculture, water, because the water can be contaminated by the ash, and climate because of the ash particles and gases in the air. So these secondary hazards, even though they're called secondary, they're not necessarily lesser hazards. They're just not always expected in an eruption. So basically, volcanoes are dangerous and powerful. We know that now, but they aren't always toil and trouble to us. Sometimes they have significance to us as well. Some villages and towns even elect to stay near active volcanoes that are expected to erupt in the future. So next, we're going to talk about the significance of volcanoes and how likely it is to predict the eruption of volcanoes. So that's going to be in our next session. So for now, I'll bid you guys goodbye and I'll see you guys next time.
Party's over.